There is a massive hidden physical layer powering modern technology. Millions of servers processing trillions of calculations every second. And the company that controls this infrastructure isn't Apple, it isn't Microsoft, and it isn't Google. It's NVIDIA, a company that started out building graphics cards for video games and now manages the infrastructure for the largest scale of machine learning in existence. OpenAI, Meta, Amazon, and xAI now find themselves in a position where their most critical operations are tethered to a single provider's hardware. This level of structural dependency means NVIDIA's internal roadmap now dictates the speed and direction of the entire tech industry. The launch of ChatGPT triggered an immediate, massive spike in the demand for specialized computational power. Training large-scale models requires thousands of specialized processors linked together, drawing massive amounts of power and requiring heavy industrial cooling systems. By 2024, the surge in demand created a global shortage of high-end processors. Cloud computing prices rose sharply as capacity reached its limit. Startups were forced to delay their product launches because they couldn't secure the necessary compute time. The secondary market saw hardware reselling for multiples of its original list price. Almost all of this competition was centered on one specific product, NVIDIA's high-performance computing modules. This supply shock effectively consolidated global market power into a single hardware vendor. It is a common misconception that NVIDIA dominates solely because they design the most efficient silicon. Their real advantage is CUDA, a proprietary software layer translating high-level code for thousands of GPU cores. Over 15 years, industry standards like PyTorch and TensorFlow were built specifically for CUDA, creating an ecosystem where modern AI software is optimized for one specific chip. This creates a lock-in effect. Switching to a competitor like AMD isn't as simple as swapping the hardware. It requires a company to rewrite their entire software stack and engineering pipelines. Because NVIDIA owns the software layer that developers rely on, they effectively control the development of the hardware itself. Beyond the software, NVIDIA also secured the physical bottlenecks of the global semiconductor supply chain. Designing a chip is only half the battle. To build them, NVIDIA relies on TSMC, the only manufacturer with the precision tools required to fabricate these specific processors at scale. As demand spiked, manufacturing stages like advanced silicon packaging and high-bandwidth memory became critical shortages for the entire industry. NVIDIA moved to secure these resources early, buying up manufacturing capacity years in advance, and acquiring networking specialists like Mellanox to integrate the entire system. This supply chain control allowed NVIDIA to bring next-generation systems to market, while their competitors were still waiting on basic components for older designs. This has created a strange dynamic for the world's largest tech companies. Microsoft, Amazon, Google, and Meta have more capital than almost any other entities on Earth. Yet for the most critical component of their future growth, they are currently dependent on a single external supplier. Microsoft is investing tens of billions of dollars into data centers filled with NVIDIA hardware. Meta is doing the same, building massive clusters to support their research. This dynamic ensures that a significant portion of the capital being spent on AI infrastructure is funneled directly back into NVIDIA's revenue streams. This leverage has led to a period of rapid financial growth, with NVIDIA reporting profit margins that are atypical for a hardware manufacturer. Markets have responded by valuing NVIDIA as the primary provider of the infrastructure required for the current wave of technological investment. But the high cost of this dependency is driving a rebellion. Google has spent years developing its own TPUs, and Amazon is pushing its Trainium chips to reduce their reliance on external vendors. There are also logistical risks. Because production is heavily concentrated in Taiwan, any regional instability could disrupt the global supply of these processors without warning. The long-term question is whether this hardware will eventually become a commodity. If supply eventually meets demand, the premium that NVIDIA currently charges for its ecosystem may begin to erode. By integrating hardware design with a dominant software platform and a secured supply chain, NVIDIA built an ecosystem the rest of the industry must use. The next decade of AI development will be shaped by the entities that control the physical and digital layer underneath the models. History suggests that market dominance of this scale eventually invites disruption, but for now, the path to the future of AI goes through a single company. Subscribe to Compute Stacker for more deep dives into the economics of hardware and the